welcome everyone to yet another year of hosting Denny Vrandečić, the person behind Wikidata and these days Abstract Wikipedia, to our class. This class is actually wrapping up the section on Wikidata, looking forward to the future. And this is part of a course that has been running at Tel Aviv University for 8 years now, and is called From Web 2 to Web 3, from Wikipedia to Wikidata. And this recording is a pre-recorded session before we actually host Denny live for a Q&A session that is open to everyone. So you're all welcome to join me in asking Denny different questions after you see this interview. So Denny, thank you again for being here. You're a valued guest lecturer that keeps coming to the course every year, and it has become a tradition that I really appreciate because we get to chat about the evolution of Abstract Wikipedia year in and year out and see how things are progressing. So I really am looking forward to this year. But before we do that, why don't you please introduce yourself?
Hello, and thank you so much for having me. And I'm very happy to be here and to have the opportunity to talk with your students. I'm Denny Vrandečić. I'm the founder of Wikidata, as Shani has said. I used to work back then for Wikimedia Deutschland when I worked on Wikidata. Since before that, I made a PhD at the KIT, the Karlsruhe Institute of Technology in Germany, on the topic of semantic web and building ontologies with a lot of people, which then led to Wikidata. Then I joined Google, working at the Google Knowledge Graph for a few years before I came back to the foundation, to the Wikimedia Foundation, to work on Abstract Wikipedia and the Wikifunctions. And I'm very happy now to be working on that and be getting very close to finally get Wikifunctions out, and I'm very excited about that.
Yeah, that makes two of us. And I guess we can defer people to our previous interviews if they want to hear more, but really very, very briefly, for those who may be joining us for the first time and who may not know, let's make some order with all the different names, right? We have Wikilambda, we have Wikifunctions, we have Abstract Wikipedia. Let's begin at the beginning, and maybe you can explain these different terms and the connection between them so it's easier for people to follow.
Absolutely. So the thing that we are working really on right now and focus on is launching Wikifunctions. Wikifunctions will be a sister project, just like Wikidata or Wikipedia and Commons. And it will be a repository of functions, meaning that people can introduce new functions, that they create tests for function, implementation functions, and that they can run functions. With functions, I mean functions in the sense of, as it meant in computer science, meaning that it gets some inputs and gives you some outputs. Typical things are adding up two numbers or giving two dates, how many years have passed between them, stuff like this. Wikilambda is the software that runs on Wikifunctions. This is an extension to MediaWiki. So Wikifunctions is to Wikilambda what Wikidata is to Wikibase. So Wikibase is the software, the extension that runs, and Wikidata is the site. Wikilambda is the extension on MediaWiki that runs under Wikifunctions. Wikifunctions is the site is a project. It's where we all work together. Abstract Wikipedia is kind of the reason why we're doing all of this, the goal of all this. Having a repository of functions is cool, but the actual goal that we are here following is to have a lot of functions that can do natural language generation tasks in order to generate Wikipedia articles that are currently missing in many languages out of abstract content. So Wikidata has structured data, but often what we want to have is, for example, an article about something about a city, about a person, about a species that currently doesn't have an article. And Wikifunctions would be the place where you can generate where you can write a function that, given then, for example, data from Wikidata, can generate an article that can be used in the Wikipedias so that we can fill in the gaps that we currently have. So Abstract Wikipedia would probably not be an actual site or something. It's more this interaction of all these other projects that we have, of Wikidata, Wikifunctions, Wikipedia together, in order to have much more content available to the readers and to allow everyone to contribute knowledge in a language-independent way so it can go to everyone.
That brings me maybe to discussing maybe some of the challenges that we've had with Wikidata. I think if maybe we can discuss that, that will make clear to the audiences that are new to these concepts why you even thought of that, why it even became a thing that we're following, because that might, again, not be clear. So do you want to maybe talk about the challenges that we've been having with Wikidata and how you see this as a solution to some of the issues that we've had?
I can take a stab on this and see if I get to the challenges you've mentioned. One of the main challenges, I think, with Wikidata is that the expressivity of Wikidata is very limited. Some things you can obviously say, like the birthday of a person or the population of a city. But if you want to say something like, when this person was growing up, they spent a lot of their summers in Israel at the beach. That's something that you can't capture in Wikidata. We don't have the expressivity to do that. And I don't see us extending Wikidata really in order to capture this expressivity, because it wouldn't be something that is repeated a lot. It's a very specific thing for this particular person, which is often also not relevant. I mean, for many people, it doesn't matter how where they spent the summers often by growing up, but it might be relevant for a given author, for example, in order to understand why they wrote a specific book. It might be relevant for a politician in order to understand their motivation and things like this. So,
or maybe to just highlight what you're saying, we're talking about structured data. We're not talking just about, expressing it as we've been doing on Wikipedia in various languages. We want it to be structured so it can actually be more easily translatable and also understood by machines. So just to clarify that this is exactly what you're talking about.
Yes. So the goal really is that we capture, and we call this an abstract representation, because it abstracts from the individual natural languages. So it's not written in English, it's not written in Hebrew, it's not written in German. It's written in some abstract representation, trying to capture the content of what we want to have in the Wikipedia article. And then we have this function that translates it back into natural language for reading. And it should be, and the goal is basically that with having this abstract representation, we have something that is easier processable by machines than natural language is today. There has been amazing progress in natural language processing in the last few days, hours, months, but we're still not.
We'll talk about that. We'll talk about that, I guess, coming up soon. But before we do that,
but nevertheless, it's one of the things with Wikipedia is that we really want to trust the content. It has to be high fidelity. Wikipedia is something where, after they've been to the doctor and got a diagnosis, this is where they go at home then to read up on what this actually means. And this is something that I don't want to have, errors sneaking in some way. It should be high quality. What we have should be high fidelity. We trust Wikipedia, and maybe more than we should, but we trust Wikipedia certainly. And one of the reasons is because the content that we have is really controlled by the community. They can, and So one of the design requirements for abstract Wikipedia is that this doesn't change, that the community remains in control of what we state in abstract Wikipedia. And if you want to process it, you can do so with high fidelity or to the content.
And I remember you giving a really excellent example, I think, of something very simple, right? Marie Curie, and the fact that she has 2 Nobel Prizes, and the fact that, yes, while we may be able to construct it, to shape it into statements in Wikidata, we can't really emphasize the current structure of Wikidata is not allowing us to specifically emphasize the fact that it's a unique thing that you got 2 Nobel Prizes, one for physics, one for chemistry, and Wikifunctions and the whole idea of abstract Wikipedia is supposed to be helping us convey these types of statements in a structured way, like we've been doing in Wikidata, just a more portions of the text on Wikipedia will be structured. Did I get that right?
Absolutely. Marie Curie is a great example. We have in Wikidata every single Nobel Prize winner, right? We have a table. We know when they won the Nobel Prize. We know in which field they won the Nobel Prize. It's all there. But the fact that she's the only person to have gotten the Nobel Prize in 2 different scientific fields is just not captured. That she and Pauli are the only people who got 2 Nobel Prizes. It's also not captured anywhere. And even simpler examples, I found even simpler examples since then. Jupiter is the largest planet of the solar system. It's such a simple fact, and we all know it, right? I mean, we all know what the biggest planet is. Wikidata, well, knows it implicitly because it knows the sizes of all planets, but it doesn't know it explicitly. There's nothing that states in Wikidata, this is the largest planet of the solar system. And this is obvious information that's important, because if you go to any Wikipedia article on Jupiter, in no matter what language, you will find that right there in the first sentence or 2. So for us as human readers, we really want to know that information. But Wikidata wouldn't give it to you explicitly. It doesn't emphasize it. It's just implicitly inside of the data set. You would only find it if you do a query like, oh, give me all the planets of the solar system and sort them by size. And then you would say, oh, yeah, your Jupiter is the biggest one. But that's really something that we want to explicitly know. None of us knows exactly, I mean, I assume none of us knows exactly how big Jupiter is, how big the other planets are. Nevertheless, we know this fact that Jupiter is the biggest one. So we don't store information in the way that Wikidata does. And with abstract Wikipedia, we want to be able to capture this kind of narratives better in order to express them in the Wikipedia articles.
That makes absolute sense to me. I guess, you've already mentioned the AI revolution that we're all experiencing, specifically Gen AI. And I guess some of the questions, even before the explosion of the past few months, we've been, every year where you arrive to this conversation, I would ask about where Wikidata and Wikifunctions and abstract Wikipedia live in this ecosystem, because to me it's sort of an ecosystem of data, and it always looked to me as if what we're doing on Wikidata is sort of infrastructure, right? Infrastructure work, and it all combines and it all connects at the end of the day. But now we actually have Gen AI, and it's not trained on Wikidata, which was a huge surprise to me, right? Like things like ChatGPT at least are trained on Wikipedia alone, and there are many challenges. So I guess I would really, want to hear your thoughts on that and to where you see the future of that. And do we still even need Wikidata? Is something that people are not sure about because of these progresses that we've seen in natural language processing in the large language models. I personally think, just finished my PhD on Wikidata. I think there's a huge place for it still, but I'm really, you're the expert, so I want to hear your thoughts on that.
Yeah. I certainly have no doubt that Wikidata will remain needed. They like really, basically no doubt. The large language models are really showing amazing capabilities. There's no question about it. And they are also having a number of disadvantages. One of the disadvantages, for example, is that they're pretty expensive to run. No surprise, you have those huge language models, a lot of parameters, and the other problem is, and it's tied very closely to it together, is that those language models also store a lot of knowledge inside of them. So if you ask, for example, a language model, what is the capital of Croatia? It will usually have this kind of knowledge if it's big enough, because it's stored in the parameters. There are billions and hundreds of billions of parameters in those things. They store all this kind of information, and they store this information for a lot of people. For example, you can ask for the date of birth of Ada Lovelace, and it might even tell you the right one. But one thing that I notice when doing experiments with those systems is, for example, that it can depend sometimes on the language in which you're asking to get a different answer. Because they are storing the knowledge, not necessarily in a language-independent way. And this can mean that you're, for example, storing the place of birth for millions of people in hundreds of languages in those models, requiring obviously those billions of parameters. And then in order to answer a question like, what is the place of birth of Lady Ada Lovelace, you actually still make a guess in the end. You generate the answer, you're basically guessing it based on the data that it has seen. And if you're lucky, you're right. And the more prominent the entity is in your training data, the more reasonable it is you're lucky, and it will be right. But you also very often can just get a made-up answer, which is simply not true. A lot of people call this hallucination. And you never know whether the answer is correct or not. And there we come again to this problem that I mentioned earlier.
Provenance and references.
And trustworthiness. If I go to Wikipedia, I want to be sure that what I see there is right. What we really need to do with those large language models is to teach them to look stuff up when needed instead of making it up whenever they want to. And in that case, again, having a knowledge base like Wikidata for an LLM to look stuff up would be tremendously useful. There's absolutely no need to keep the place of birth for millions of people inside of a language model. Spend all those parameters on this kind of information. It's much, much more efficient and cheaper to just store it in a knowledge base. Also, it allows you then to edit the knowledge base. It allows you to understand what's in the knowledge base, to keep, as you say, references in the knowledge base, like to know where this information is coming from, to keep the provenance of the data, and to edit it in case it changes, in case it's wrong, to contribute new people, and so on. How do you even tell a language model reliably that, oh, this is new interesting person that you should know about, and here's facts about them, and so on. All of these things are widely underexplored with LLMs and pretty much solved with knowledge bases. So having Wikidata as a system of support to an LLM makes a lot of sense. Replacing Wikidata, internalizing all of the knowledge of a large knowledge model like Wikidata into an LLM seems to be a highly expensive approach that I just can't imagine to run well. I mean, I did some some estimates of the costs of storing the stuff in an LLM compared to storing in Wikidata and generating it again. Never mind the fact that whether it would be correct or not, but it's also like 50 times more expensive to run an LLM than running a knowledge base.
So it's a matter of cost, but if I'm hearing you correctly, not only the cost. I think two things really struck me as important in what you said specifically in this context. One is that we care not only about English. I mean, most of what we see today exists in English and maybe some other big languages that have good LLMs or like good corpus that they can train their Wikidata upon. But we as Wikimedians know that once you get out of the, I don't know how many languages, but the 10 biggest ones, there is a huge drop in the quantity of articles and the quality sometimes. And so we know we have a huge amount of work to do to continue curating all of human knowledge in all languages, etc. So I think, on that front, Wikidata is still the best way, and Wikifunctions as a contributing or like another layer of sorts. I see it as another layer of just allowing us more structured data to be created and used by humans. So that is one aspect. The multilingualism is one aspect where I think we can be extremely useful. But I'm also seeing some possibility for symbiosis, right? Like, for instance, ChatGPT it's notorious for many reasons, mainly as Wikimedians, because it doesn't have the provenance and the references. And I know that we're working on it, and maybe future generations of ChatGPTs as a generic name for all, Gen AI, would know how to give us the references. As of now, they don't, and it's a huge deal for anyone looking for reliable information. But I think where it's really good is actually knowing how to program. And I think, you've talked a lot about contributing to knowledge and curating information on Wikidata, which is, and Wikifunctions, and then creating articles with it. And I think the other side of the coin, or at least one additional side, or one additional use that we have for this knowledge base is that we can query it. And if we had any threshold that was really blocking people from interacting, because adding content is fairly easy for newcomers, but in order to extract information, you actually need to know Sparkle. But hey, ChatGPT really can generate Sparkle queries quite easily. You can tell it what you want in a natural language, which we've been dreaming for a decade about something like that. So when I talk about symbiosis, I could actually see a platform or some sort of interface, some app that allows you to actually speak in natural language and say what it is that you want and get the query result, visualize the way that you want them without needing any Sparkle. So I think there are ways for it to go both ways, to be helpful. And I do hope that the next generations will be using these structured data, including from Wikifunctions, and we will be just able to have more structured data of more of the world's knowledge. But I'm really curious to hear what you think about all of that.
Absolutely. No, you're completely right. And I'm super excited about these possibilities. So if you don't use LLMs as knowledge models, but if you use them as language models and use them, for example, to understand natural language requests and translate it, for example, into a format that our tools then can answer, that's just pretty amazing. I was using it for a number of things. Actually, I know Sparkle pretty well, But still, I'm getting to the point that for more extended queries, I'd rather ask ChatGPT to create me the Sparkle query than copy and paste it and look at if it's right and fix a few things or something like this. And this is happening on, on an untrained ChatGPT model. It's not like they have trained it to make Sparkle queries for Wikidata. This is just zero shot, and you can ask queries. And queries that I have asked are like, give me a list of German computer science professors. Works perfectly. It just creates the Sparkle query. It works out of the box. Give me a list of Croatian actors and where they are born, because I wanted to know how frequently they are born in Zagreb and so on. It does that as well. Another thing that I just did last week with Lydia Pincher, she's PM on Wikidata, we got the query, give me all the female science fiction authors that are born in May. And again, it did that query like out of the box, and I don't even remember if I had to do any fixes or if it just worked. This is amazing. This is really, really cool. And we could train this further on Wikidata, do some refinement for the Sparkle queries. It sometimes gets the QIDs wrong, or it makes new QIDs up, and so on. Because as I said, this is an untrained model. This is just the base model of GPT-3 or 4, and it's already this good. So with a bit of training, I could totally see that this could be pretty amazing and allow us to provide a completely novel interface to Wikidata's knowledge base to answer queries that we currently don't ask, even because they're like, oh, we don't even think this is like, I mean, list of female science fiction authors born in a specific month could be really cool for a number of websites to show them and highlight those people, but we currently don't ask this thing. Or like, give me a certain set of people that have birthday today. You could like add this to your website on a specific topic and just like highlight every day someone else and get a picture from comments and so on. There's so much thing you can do where we currently often lack the skills or the time to do it, and where the LLMs could really help us to enable more people to actually access the wealth of knowledge that we have in Wikidata. I'm super excited about it.
Yeah. Same here. I think at this point, though, I have to say, it, like very much in parenthesis, that I trust more its ability to create a Sparkle query that I'll then throw back to our query service and do the tweaks that are needed. So still having like a Wikimedia eyes and someone with data literacy that can, see if the results make sense, etc., rather than actually trust it to give me the query results, because I have seen it, especially when you do lists of things, it can generate things that look absolutely real, but are absolutely bogus and just don't exist, or use like real names. I asked it, I just shared it recently in an EduWiki conference, but I talked to ChatGPT about data literacy, and I was interested to see if it can curate articles, academic peer-reviewed articles. I was very specific about wanting the references and wanting to receive references from it. And it gave me a list that looked really real. And then I checked one by one, and it was all fabricated. So some of the names of the people existed as researchers, but the articles were never written. The journals were all made up. So actually bogus results. So I would, at this point, a long way to say that I would not trust the list that ChatGPT gives me, but I would trust the query results more at this point, at least, until we get right the references, etc. And maybe, apropos discussing our challenges of Wikidata / future issues that I think will be expanded to Wikifunctions, and we need to consider probably as a community, and I would like to hear your thoughts on it, are the references and the modeling issues, because actually we all know that because we don't have a really strict modeling for items of the same category, Sometimes that means that the results of the queries are not as accurate as they could be. That's one issue. And the second is that we need a really better system for understanding or kind of grading the references. Because yes, we can have references on a good day for every statement, which is not the case. But let's say that we're optimistic and we get to a point where we actually have references. How do we know if the references are good ones or not? And this has become an increasingly important task in terms of, the reliability of everything, the truthfulness, as you called it at the beginning of this talk, in terms of just making sure that people are understanding where it comes from and whether or not they can trust it. So I think we will need to evolve in a sense, as a community, to have better tools for referencing and for figuring out these modeling issues. Otherwise, we're not going to give good results that would be able to complement or to help expand the large language models that are based on Wikipedia. And that would be a shame, I think.
I fully agree. The LLMs open up so many possible new tools, particularly for our contributors. My favorite model of working with these machine learning AI systems is to always use a human in the loop system, basically, and to empower our contributors to make them more effective in order to contribute to the Wikipedias. So in the end, I still would love to have every single piece of fact that we have in Wikipedia or in Wikidata to be checked with a human eye in some way. That doesn't mean that that our contributors have to sift through everything themselves and things. I totally don't mind if someone would take a summary done by an LLM and then check it against the actual sources and then put it up into Wikipedia. The important part is the checking against the sources part. It is important that we always have this human in the loop. But there's so much that LLMs can help us with. My favorite thing would be actually some tool that just takes a Wikipedia article or a Wikidata item, doesn't matter, and looks for each reference that is given in that page and checks whether it actually supports what is being said in the article. That's something that now with LLMs become a possibility to actually create. Right? We can actually say, okay, here's the source, here is the article. Is what we claim that the source supports actually really giving in the thing? And I wouldn't trust this to do that automatically, but I would totally trust it to say, oh, make me the list of the
Here's
things
some
that
suggestions. Yeah. Here's a list of suggested claims or suggested articles to add, or absolutely.
Our good articles have 100 or 200 sources. If I had a system that tells me what are the sources that look most bogus to you, and I get 4 or 5 of them to check. I mean, if they all check out, I'll probably say, well, the rest is probably fine too. But if they start they look all wrong, it might give me reason to investigate further, for example, into the article. I remember there was a paper at the Web Science Conference in 2012, I think, or even earlier in Koblenz. The paper was, what they did was they showed different Wikipedia articles to readers and asked them how trustworthy is the article. So what they did is they had an article without many references, they had an article with a lot of references, and they had the second article with a lot of references. But in the second case, they just copy and pasted the references from a completely unrelated article and sprinkled the references within the article. So it had all the references had nothing to do with the given article. And the two and no one cared about the actual content of the text. It was all how many references do I actually see? And it didn't matter whether they were actually supporting the text or not. We are so trained by Wikipedia that if we see a lot of reference to the end, oh yeah, this sounds good. It is probably all fine, and we start trusting it.
Yeah, it sounds like, some of the potential for this collaboration between Gen AI and what we do as humans who are curating knowledge can certainly be the development of tools based on AI
Yeah,
that will help us flag or help us check these references. But that requires, again, a lot of development that still is not existing. And it's making it a really exciting times for us, I think, in the movement in terms of the possibilities. But I'm curious to know, because I want to take it back. As every conversation these days, everything is rotating towards Gen AI, and I'm surrendering. But that's fine. But I do want to. I did invite you to talk more about abstract Wikipedia and Wikifunctions and Wiki Lambda, the base for all of that, like the infrastructure, the technological infrastructure. And I'm curious if what's happening is actually affecting the plans that you've had in terms of development. Are you like reconsidering things or thinking again about the interface, thinking again about how it will all work now that we have these platforms? Because I know it's been in development for some time and we're looking forward to seeing it actually work. And I'm curious if these developments are actually allowing you to do things differently. Because I think in previous years, maybe another sentence in parenthesis, I think one of the things that we've kept discussing over the years in various occasions have been that, we've had Wikidata for a decade now, and it was such an amazing experiment, and we've learned so much about it, including the things that don't work well or that are still challenges for us. And like, how can we as a community make sure that we're not replicating these in a new project that we're building? And I guess, yes, that's where I'm coming from. Like, is this actually influencing what you're working on these days?
it is. It certainly is. We had it from the very beginning, the idea, for example, that we would use a magical system that allows you to just enter natural language text and then creates abstract content out of it. And you, as a contributor, then check whether this abstract content looks like this. Does the generated text looks right from that, for example. And now that's something that's actually possible. I'm totally amazed by the fact. I didn't expect it to be possible before we launch even. Now it's something that we can do very, very quickly, which is cool. Another thing that I was hoping for, so in Wikifunctions, we have the ability to define functions, describe them, give them documentation, write tests for them, and so on. And this is back then, even when we started Wikifunctions, to work on it, it was like, oh yeah, this is the perfect area for program synthesis and so on. There was a whole research area into creating programs that fulfill certain conditions, like, for example, tests and so on. And this was an active research area, and a lot of stuff was going on in there. And now it is somehow, oh wait, we actually just can use a language model for that. We can use even the natural language description now. We have the tests and so on. We will probably be in the situation that you will be able to to suggest a function for Wikifunctions, enter a few test cases, and then just ask, like with a click of a button, ask, okay, give me now a Python implementation for that. Oh, looks good. Click store. You don't even have to implement the things anymore. I was always worried that these implementations would be the big bottleneck. They would like slow us down and so on. Maybe not. So now we can probably grow Wikifunctions at the speed of ideas instead of the speed of available development skills, which is pretty cool. I'm very happy with that, and I'm super happy to actually to make sure that we can use the new results in LLMs and code generation for exactly these kind of things, that all of the things work together, and so far they're changing our approach, they're changing our thing in order to make sure that we can actually benefit from the progress in this area. It would be silly not to.
That's really good news. And And I'm kind of curious if there's anything that you can actually show us. Like, how does the interface look like right now? Or are we still not ready for that?
Oh, I think I can show you that. Let me.
And maybe we can then talk a bit more. I think last time that we talked, it was really interesting to better understand how it's interfacing back with Wikidata. Like, this is an extension of what we've been doing on Wikidata, and just better understanding how it all works together, all these different systems.
That part I can't demo yet. We haven't implemented it yet, but I can demo you Wikifunctions itself. So in Wikifunctions, well, we have a list of functions. This is no surprise. So, for example, give one here. This is the function for. I start with a mathematical example and then go on with a natural language example. So something that we've just been working on is can't find it right now. The factorial. Factorial. Here we go. Of positive integer. So this is a function that if you give a number like 3, you get the factorial back, which is in that case 6. The factorial is you multiply the number with every number below it. So the factorial of 3 is 3 times 2 times 1 is 6. The factorial of 5 would be 5 times 4 times 3 times 2 times 1. So you would get actually to 120. This part is being redesigned right now, so this is not how it will look like in the end. So for each function, like here, for example, the factorial, we have, in this case, a number of implementations, one in Python, one in JavaScript, one in composition, and we have tests. So the factorial of 1 is 1, the factorial of 3 is 6, and so on. And we make sure that all of the implementations that we have run against this and pass and so on. So, for example, we can read it here in Python, and we basically get the code telling us here we just multiply. Well, you need to read Python for that. So we multiply it with all the numbers below the given number. And so this is now but basically we have all these different implementations, and we can run them, and the system decides in which one to run, and you can just have this library of things. Now,
sorry for the Mogul question, but why would people actually want to create this function in different languages, I guess, program languages? So I see Python, I see JavaScript.
Yeah.
What is composition? I don't know, but you'll tell us.
Composition is my favorite, actually. Composition is composing a function from the existing functions that we have in the system. So we have, for example, if function and is zero function and so on. So it's actually taking these and composing them. The nice thing about composition is that all of these functions are functions in Wikifunctions, and therefore have their labels in different languages. So we have, for example, labels for factorial here in different languages. So we can look it up in German. And it doesn't show me right now. This is the implementation, sorry. I need to be in the function actually to see that. So I can see that it has in different languages and so on. And then I can see even the composition in different languages. So people can actually compose functions in their own natural language. It doesn't have to happen in English. Most programming languages are based in English, which is a big hurdle for people to actually code. We can see that very nicely in the add s to end. So this is a function that, given some input, like for example book, and I call it, it will just add s to the end. Just not particularly smart about it. It just adds s to the end. It doesn't do anything else. And here again, I can see there is a composition of this thing, and just is concatenate the actual argument that you have with s. That's what's happening here.
Well, is it smart? Does it know that if it's a baby, it would be IES, or that sometimes it needs ES, or no, it doesn't know?
In this case here, it doesn't. So if I enter baby, it will just add s to the end, because this is what the function does. It adds s to the end, so it makes baby. We do have a function which is the so-called smart paradigm for the English plural. So in here, if I enter baby, it will give me babies. So because the smart paradigm is, well, smarter. So if I go here to the implementations,
it would have all the rules for.
It has more rules of it than those. Like, for example, if it ends with Y, it replaces the Y at the end with IES. If it ends with man, it replaces the man with men, and so on. So it has a number of more rules of that. You can see not all of them are still good. Like human would turn to, should be human, not human. Right now, if I enter it, it's not. So this, but this is just the beta that we're working on, right? I mean, in the end, the community would be doing much smarter things that we have. And we always have Wikidata in the backend to actually use this first and look it up if it's an irregular form, for example.
But the idea essentially would be to be able to be in a Wikipedia interface, writing an article and just calling different Q numbers and P numbers and functions, which are Z. I see.
Yeah.
Okay.
Then you can just call them inside of your of the wiki text, and the result would then be integrated into the Wikipedia article. So this is what I wanted to show. If I go here and change language interface, we still need to actually work on the actual switcher. All of this should be shown in German, I hope. Yep. So you see the actual implementation as a composition here now in German. So I can actually code stuff in my own natural language. Better, we don't have too many languages currently, but this would be the idea. So
again, when going back to the idea of abstract Wikipedia, right? Like having more of the just text that we are used to seeing on Wikipedia now, it's easier to say, oh, the info boxes come from Wikidata, or we extract some of the facts from there. So the idea would be that we extract just more structured data from Wikidata and from Wikifunctions. Is that how it's going to work?
We would extract more of the data from Wikidata, but we would be also able to make completely new statements in Wikifunctions directly. The example with Marie Curie, for example, is something we don't have to extract every time. We don't have to run the Sparkle query to ask this on the page of Marie Curie. That would be very inefficient and expensive. We can just make a constructor that says, no, Marie Curie is the only person that, and then have the condition attached to that. So not everything in abstract Wikipedia needs to come and be supported by Wikidata. We can add more information that we actually express in Wikidata to it in order to circumvent what we were discussing earlier, the limitation of the expressivity in Wikidata. What are other good examples? There's a lot of information that you can't really put into Wikidata. Like, for example, you can't express how does photosynthesis work, or what led to World War II, what were the events that led to it, because we just simply don't model the world in so much detail in Wikidata. And in Wikifunctions, you can make those things and express them and have the information be represented. As long as I have a way to put it into an abstract representation, independent of a natural language, and then translate it confidently with high fidelity in the individual languages, I can add it into abstract Wikipedia and create it in the languages.
That's fascinating. And I think, again, you speak and I think of the ecosystem of data again, and how, in a sense, fragmented it all is at this moment, with some apps giving us details. Like if we think of Siri and Alexa, they do give us answers based on Wikidata, right? Gen AI is not. Either of them is really giving us maybe the good reference. Sometimes Siri would say, Wikipedia says that, right? But I guess what I'm, as an educator, what I keep thinking about is this new type of literacy that I still don't have a good name for, that is actually needed these days to interact in a wise and informed way with data. Do you have anything that you want to share regarding that?
I do. We have basically for thousands of years, we have learned that control of language means intelligence, right? If we have something that talks in smooth and good language, we believe them. It must be a smart person. There's reason to trust. I mean, this is how. There's so many. There's so much in our culture that shows that, being good with words means that you're smart. And now we have these LLMs, which are really good with words. They're certainly better with English than I am, but they're not intelligent. They're still, or if they are intelligent, they're very differently intelligent than humans are. We believe that a conversation is something that kind of takes down our guard. We believe the other person a lot in a conversation in general. That's why we're talking. We wouldn't be talking with people we don't trust so much, right? I mean, we switch to a different mode than when we're just reading a text, and just taking the content of a Wikipedia article and turning it into a conversation gives us, as you say, a very different access to this knowledge. On the one side, it's great because I can ask questions and get answers and so on. On the other side, it pulls my guards down even further. It makes me more susceptible to believe the thing. We know that the medium is the message, right? We know that the way we get information, the mode we are presented with information, has a strong effect on our readiness to believe it. And suddenly having those conversational agents that feel so friendly, so nice, so convincing, that speak so well, I don't think we're yet trained, and we don't yet understand how to evaluate what they are saying, basically. Unlike me, they're not stuttering. They are really good with language. They will be super patient in answering all the questions, right? I've seen my daughter interact with one of those, asking questions on, and she immediately got drawn in. It felt like, wow, someone is really answering her questions, and it feels super scary as well. Especially if you know that it's just making stuff up. So yeah, I don't have answers, but I certainly have a lot of thoughts. On the other side, I just read a book. I got recommended. I was reading the book, and everything felt like a little bit off. And only in the end, I came to the acknowledgements to find that the authors have heavily used GPT to generate a lot of the text. And I felt very betrayed at that point. I was like noticing already, like reading the book, it's like this book never really goes into depth. It sounds nice and everything, but it stays on it's almost like a high school essay. It doesn't feel better than that. And it was written by professors in the field. I was expecting a much more substantial discussion, and yeah, you don't get it. So I think the following years will be very interesting for us to learn how to deal with this new modality. Sorry, I'm ranting.
No, not at all. I think what you're describing is exactly what all of us are feeling, which is a mixture of horror and confusion and fear of what's coming, but also a lot of optimism and a lot of new possibilities and a lot of desire to experiment and explore and open up new possibilities. I'm heavily trying to focus on the latter than the former. But I think as an educator, and also all of us as Wikimedians, kind of interacting with the world and kind of being stewards of free knowledge and hopefully free, reliable knowledge. We're thinking about the other side as well, and about our role in helping all of these systems work well, especially knowing that everything we do now is actually exponentially is more important. Because if we've been fighting, fake news on Wikipedia, we've been doing it for years and years now. It's not news to us. The idea that there is vandalism, there is misinformation, disinformation, missing information. Every Wikimedia knows that. That's part of our daily lives. But suddenly, because the content that we're generating is being used to train these LLMs, and to my understanding, Wikipedia is a huge portion of whatever the rest of it is. Yes, they have much more than just Wikipedia, but Wikipedia is like a core component, and it's actually the more reliable part of the more reliable portion. So suddenly it's on a completely different level what we're doing, because we're actually also helping to fight or not fight, rather train or make more educated these LLMs, these Gen AI apps that will end up giving us answers. So to me, it seems like Wikimedians now have an even more important role than before, also in trying to explain this landscape to people. So yeah, in a sense, even more work for us. But I'm also very hopeful, because I think, as you said, it's a moment where suddenly we can build tools to really help us do some of the work that we couldn't, that would be manual labor, difficult to do for humans. And suddenly Gen AI can actually help us do this better. So I'm remaining very much hopeful, looking forward to seeing what folks like you do, and kind of the types of tools that you'll be developing to helping us actually do our work better. And so I remain optimistic, cautiously optimistic at this point. And I was wondering if you want to add anything on top of that.
Oh yeah. So first, no one should be waiting for me to do tools. I'm busy with abstract Wikipedia and Wikifunctions, but there are a lot of tools that can be done, and I hope that folks will do it. So I'm hoping that some of your students might find it fascinating to maybe pick this up and do it, or someone else listening in right now. There's so many things that can be done. If I'd have more time, I certainly would be playing around with those things and trying to figure out. Also, the thing is, no one really knows where the limitations of these systems is, what they all can do, and so on. This is a perfect time to just play around and fool around with those systems to see how far we can push them in order to be helpful and do stuff. So yeah, it's a great time. It's super fascinating. I totally agree with you. It's exciting.
Yeah, we live in a fascinating time in that sense. And on that optimistic note, I again invite everyone to get inspired by everything that Denny shared today. And if you have follow-up questions, please send them to me, and we will ping them to Denny on our Q&A. The video is going to have the dates for the live section, the live Q&A that you can all join. And with that, Denny, again, thank you so much for being a returning guest. It's always fascinating, and it's actually fun to see how we've been doing it, I think, 4 or 5 years now, to see the evolution and to actually share the different ways of this evolving. It has been a fascinating journey, at least to me. So thank you for all your work and for the inspiration. And I look forward to hearing the questions that others have in the movement, and my students as well. So thank you.
Thank you so much for having me, and I'm also looking forward to the questions.
See you later on. Bye, everyone.